Yes, I welcome you guys. And today I'm going to summarize for you the chemical properties of period 3 elements, specifically reactions with air, reactions with water, and possibly reactions with acid. So we shall move slowly over this and we see how it ends. Period 3 elements include sodium, magnesium, ammonium, sulfur, phosphorus, and chlorine. Yeah, so we want to see how these react with how they react with different substances, and we shall begin with reaction with air. Reactions with air. Now, period 3 elements, yeah, we looked at the introduction about the melting points of these elements, which I will summarize and post a video here. But to begin with the properties, we shall begin with sodium. Sodium reacts with oxygen to form sodium oxide. You have to specify which component of air because we believe that some elements react with magnesium. So after every statement, you have to write the equation. Sodium, yeah, solid reacts with air, which is oxygen in this case, to form sodium oxide. So form sodium oxide. Then, but we know that when oxygen is excess, instead sodium peroxide is formed. So we have to also involve that sodium reacts with excess oxygen when heated, with excess oxygen when heated to form sodium peroxide. We are not interested in those observations, sodium peroxide, roof frame, whatnot. No, sodium peroxide, just be brief and precise. What you need to show us are the conditions and the products. Conditions and the products. That is all we need from you. Conditions and the products. So if you can show us that, then you will be safe. Conditions and the products is all we need from you. Then the equation, of course. So writing this equation, as you're writing the equation, we shall have sodium plus oxygen. We shall form sodium peroxide. Solid from sodium peroxide. That is when oxygen is excess. Then from there, we go to magnesium. Magnesium has to be heated. So we shall say heated magnesium burns in oxygen to form magnesium oxide. And you can write the equation to magnesium plus oxygen gas, we shall form magnesium oxide. Don't also forget that heated magnesium reacts with nitrogen in air form magnesium nitrate. Form magnesium nitrate. Equation: magnesium solid plus nitrogen gas, you form magnesium nitrate solid. So that is how magnesium reacts. When it goes to aluminium, you have to talk about each element of period 3. And we say that the elements are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Of course, argon being an inert gas is not reactive at all. So after magnesium, we go to aluminium. So aluminium is stable. Aluminium is stable in air. When we say it is stable in air, that is the stability is due to the formation of the thin layer of aluminium oxide that resists further reaction. So it's stable in air, and that one is at ordinary temperatures. At ordinary temperatures, yeah? And that is due to formation of a thin layer of aluminium oxide that resists further reaction. But when that layer is removed, aluminium, when heated, reacts with air to form aluminium oxide and aluminium nitride, depending on which component of air. So when the layer is removed, heated aluminium reacts with oxygen and nitrogen to form aluminium oxide and aluminium nitride, respectively. Aluminium oxide and aluminium nitride, respectively. So you can write that those two equations where we have aluminium reacts with oxygen to form aluminium oxide. So I've put here 2, let's put here, no, actually I have 4. I've put here R2, let's put here R3. Then for a nitride, we have aluminium plus nitrogen forming aluminium nitride. That is for nitrogen. Then strongly heated silicon. Now for silicon, it must be strongly heated. Those conditions are needed. Strongly heated silicon reacts with air to form silicon dioxide. forms silicon dioxide. So the equation is silicon solid plus air, we shall form silicon dioxide. Then after silicon, we go to phosphorus. When phosphorus burns in limited supply of air, phosphorus burns in limited supply of air. Let me say oxygen, to form phosphorus 3 oxide, from phosphorus 3 oxide. So when there is limited supply of air, we form phosphorus 3 oxide. So phosphorus is the tetratomic molecule which is burning in air, oxygen, to form phosphorus 3 oxide. And that is in a liquid state. So phosphorus 3 oxide. But when oxygen is excess, phosphorus burns in excess air, particularly oxygen, to form phosphorus 5 oxide, to form phosphorus 5 oxide. So the equation is phosphorus solid plus oxygen to form phosphorus 5 oxide. Then when you go to sulfur, sulfur must be heated. Heated sulfur reacts, or let's say burns, to form, burns in air to form sulfur dioxide, sulfur dioxide. Those are two different words. So we shall have sulfur as a solid reacting with oxygen or burning in oxygen, form sulfur dioxide gas. Then you have to show me that chlorine does not react with, when doesn't react with air, be it oxygen or any with air, under any condition. Under any condition. So those details prove to us the reactions of period 3 elements with air. All right. Then from here, let's look at the reactions with the water. How these elements react with the water. How do these elements react with the water? Reactions of period 3 elements with water. We shall begin with sodium. You have to tell us how they react. You can involve the kinetics or the rate at which the reaction takes place. Yeah. So we begin with sodium, and sodium reacts vigorously. Sodium reacts vigorously with cold water. Sodium reacts vigorously with cold water to form sodium hydroxide, form sodium hydroxide and hydrogen gas. So we shall have the equation sodium plus cold water forming sodium hydroxide and hydrogen gas. So equation balancing, put 2, put 2, put 2. Then magnesium, the second element being magnesium, reacts slowly. Magnesium reacts slowly with cold water. Reacts slowly with cold water for magnesium hydroxide and hydrogen. So we shall have magnesium reacting slowly with cold water from magnesium hydroxide and hydrogen gas. We shall prove this point when we go to group 2 elements, where we say that reactivity increases down the group 2 elements. So after this, we need to know that when you heat magnesium, heated magnesium, reacts with the steam and rapidly. That's rapidly with the steam. Heated magnesium reacts rapidly with the steam. All those are marking points. To form, when it reacts with the steam, it forms magnesium oxide. From magnesium oxide and hydrogen gas. So we shall have magnesium reacting with steam, which is what I said, to form magnesium oxide and hydrogen gas. That is it. Then the other element is supposed to be aluminum, but aluminum doesn't react with water because of the protective layer of aluminum. But when this layer is removed, heated aluminum reacts with steam to form aluminum oxide and the hydrogen. But the other first point, you need to first mention it. I'm reading it. You have to first write it. When you're asked to describe the reactions of period 3 elements with water and you reach aluminum, first tell me that aluminum doesn't react with water and give us the reason, because of the protective layer of aluminum oxide. However, when this layer is removed, heated aluminum reacts with steam to form aluminum oxide and hydrogen gas. So you have to be very realistic as you're writing these things. Then here we shall have a 3. Then you go to another reaction. Silicon. Silicon, it must be heated to red hot. So red hot silicon, even if you say heated silicon, red hot silicon reacts with steam to form silicon dioxide or silicon 4 oxide, one can call it silicon dioxide, or silicon 4 oxide and hydrogen. My question is silicon solid plus water in gaseous form, we shall form silicon dioxide, which is a solid, and then hydrogen gas. Then others, phosphorus and sulfur, do not react with water. Phosphorus, you have to note those ones which don't react, also you have to involve it. Phosphorus and sulfur do not react with water. That is a mark. Do not react with water. Then chlorine. Chlorine disproportionates portion. Disproportionates in water to form chloric 1 acid and hydrochloric acid. One can call it hypochlorous acid and hydrochloric acid, or chloric 1 acid and hydrochloric acid. So Cl2 gas plus water liquid disproportionates reversibly forming hypochlorous acid and hydrochloric acid. So those are the reactions with the water. So let me summarize the reactions of these elements with sodium hydroxide. Yeah, reaction with sodium hydroxide. Reactions with sodium hydroxide. This is a very common question. Reaction of these elements with the sodium hydroxide. The first two do not react with the sodium hydroxide. So you have to first note that sodium and magnesium do not react with sodium hydroxide. So sodium and magnesium do not react with sodium hydroxide. But other elements, we are going to look at how they react with sodium hydroxide. We shall begin with aluminium. Aluminium reacts with hot, concentrated sodium hydroxide, hot concentrated sodium hydroxide to form sodium aluminate from sodium aluminate and hydrogen. From sodium aluminate and hydrogen. Here you can write very many equations, but you can write molecular equations or ionic equations. Ionic equations, you know, they are always easy to write, but what I'm meaning is that aluminium reacts with sodium hydroxide Actually, this one takes place in presence of water to form sodium aluminate. From sodium aluminate, this is a form, and hydrogen. Yeah. Or one can write it as aluminum plus sodium hydroxide plus, when you consider 2 molecules of water, you're going to form still sodium aluminate, but of this form. Sodium aluminate and hydrogen gas. Or still you can write it as aluminum plus 6 sodium hydroxide plus 6 molecules of water. And here you will form sodium aluminate of this nature. Plus 3 hydrogen. These equations, to get them in the head, you must practice. Now, you can as well write ionic equations of these, or you can write ionic equations for this. You have 2 aluminum for the first one, plus 2 hydroxide ions, plus 6 molecules of water. You're going to form 2 aluminate ions, and the hydrogen gas. You do for the rest. You can say 2 aluminum, because they're solid, plus 2 hydroxide, plus 2 molecules of water. You're going to form 2 aluminate ions, aqueous, then plus 3 hydrogen gas. Or you can write 2 aluminum plus 6 hydroxide ions plus 6 molecules of water. You're going to form aluminate ions. You're going to form 2 ALOH 63 minus aqueous, then plus 3 hydrogen gas. So any of these 2 equations shows the reaction of aluminum with concentrated sodium hydroxide. Then when we go to, after aluminum, we shall go to silicon. Silicon reacts with both dilute, because they are not specified whether dilute or concentrated, both dilute, or if you say both, you use and concentrated. Let me write the symbol, sodium hydroxide, to form sodium silicate. From sodium silicate or silicate ions, and hydrogen gas. Molecular equation would be silicon solid plus sodium hydroxide aqueous in presence of water liquid, we shall form sodium silicate that is sodium silicate. Silicate is valence 2, sodium valence 1. We shall say sodium silicate. One plus hydrogen gas. Is it balanced? Silicon 1, silicon 1, sodium 2, sodium 2. Oxygen is there too. Oxygen there are 2, 3. These are 3. Hydrogen is 2, 2, 4. So it is just like that. Or you can write for me an ionic one where you have silicon solid plus 2OH plus water form the silicate ions. From silicate ions plus 2 hydrogen gas molecules. So that is how silicon reacts. Then, for the case of phosphorus, the main thing members is the equations. Phosphorus reacts with hot conc, hot concentrated sodium hydroxide. Let me use the formula, but write all words to form. We form phosphine. Phosphine is a gas. We form phosphine. And phosphonate ions, and phosphonate ions, or you can call it sodium phosphine, sodium, you can call it sodium phosphonate or sodium phosphonate. Equations. Phosphorus is a tetraatomic molecule. It reacts with sodium hydroxide and in presence of water. To form, I began with the ionic equation, but we shall form phosphonate ions, that is H2, PO2 minus. This is phosphonate ions, and we shall put here a 3, then plus phosphine. Phosphine gas is pH3. That is phosphine gas. Or molecular equation would be phosphine, P4, solid plus sodium hydroxide, 3 of them, plus 3 water molecules, form sodium phosphonate, NaH, H2, PO2, aqueous, but 3, then plus phosphine gas. That is how phosphorus reacts with the concentrated sodium hydroxide. Then when we go to sulfur, sulfur reacts with hot concentrated sodium hydroxide to form with the sulfur, we form sodium sulfide and sodium sulfite. From sodium sulfide, and sodium sulfite equation, we shall have sulfur plus sodium hydroxide we shall form sodium sulfide and sodium sulfite and water. Ionic equation, 3 sulfur atoms we shall form sodium sulfide or sulfide ions and water. That is for the case of sulfur. But if sulfur is in excess, we form thiosulfate, not sulfide ions. So if sulfur is in excess, or when sulfur is in excess, you have to note this word. When sulfur is in excess, your sulfate ions, your sulfate ions are formed instead of sulfide ions. Implying that there the equation would be, it would be sulfur plus, let me first write the molecular equation, sodium hydroxide, still shall form sodium sulfide, but this time around we shall form sodium thiosulfate. And water. Ionic equation would be sulfur plus six hydroxide ions to form sulfide ions 2 plus thiosulfate, and then 3 molecules of water. So that is for the case of when sulfur is in excess. Yeah, then for chlorine, chlorine disproportionates in both dilute and concentrated. It disproportionates in the presence of both dilute and concentrated concentrated sodium hydroxide. So let's see how that one takes place. So let's say chlorine is proportionate in cold dilute sodium hydroxide to form chloride ions, that is sodium chloride, form chloride ions, chlorate 1 ions, that is from hypochlorite, sodium hypochlorite, chlorate 1 ions, and water. How does this take place? We shall form chlorine, we shall write chlorine plus sodium hydroxide. We shall form sodium chloride plus sodium hypochlorite and water liquid. Sodium's there too, so here put a 2. Yeah. So this is chlorine plus sodium hydroxide, giving us sodium chloride, sodium hypochlorite, and water. You can write the ionic equation since we said we form chloride 1 ions, chlorate 1 ions, and water. So you can write it in ionic form. Chlorine gas plus sodium hydroxide give chloride ions plus chlorate 1 ions, then plus water. Then you need to know that these chlorate 1 ions we have formed can undergo further disproportionation when you heat, and will form chlorate 5 ions and chloride ions, meaning that the yellow solution of the chlorate 1 ion will turn colorless to the formation of the chloride, of the hypochlorite, of the chlorate, sorry. So this is yellow. When it forms a chlorate, turns colorless. So the equation for further disproportionation of sodium hypochlorite, as you can see, it disproportionates further. It forms sodium chlorate and sodium chloride, meaning here I put a 3. Or if you had written ionic, it would be 3 chlorate 1 ions, it's proportionating form of chlorate ion, and 2 chloride ions from this. So that is how chlorine reacts with dilute, cold dilute sodium hydroxide. Let's see how it reacts with the hot concentrated. With the hot concentrated sodium hydroxide, we shall form different products, and that is chloride ions. We form chloride ions and chlorate 5 ions. So we shall have chlorine, sodium hydroxide shall form sodium chloride, sodium chlorate, and the water. Or you can write this equation as chlorine plus 6 hydroxide ions, giving you 5 chloride ions, because you form chloride ions, plus chlorate ions, and water. I request to end here for today. Our next lesson, I will look at reactions of these elements with the dilute acids and chlorine. Then we go to the compounds. I wish you all the best. Mighty God bless you.